This is Jack Jackson. In this video, we're going to start a series of videos where we're going to survey various types of elementary functions that you've seen before, and with particular emphasis on noting where we have continuous functions and where we have discontinuities. In this video, we're just going to kind of make a list of some of these in categories, and then we'll start with the next video in taking them sort of category by category and just kind of review some of the most basic characteristics and look at some examples. Now, in each of these cases, you're going to see more detail in my videos on algebra, trigonometry, or statistics, depending on which course these come from. And if you look at those videos, you can get a lot more detail of the development of these different functions. Here I want to just mainly focus on a quick review of the overall characteristics and which ones are continuous, which ones have discontinuities. Also, the review chapter of your calculus textbook would be a good thing to look at and review for some of these things. So remember, a real valued function is a continuous function if and only if it's continuous at every point in its domain, and its domain is a single interval of real numbers. So it needs both of those two things to be a continuous function. So there's certainly functions that are continuous at all points in their domain, but their domain's not a single interval, and of course those have a discontinuity where they're undefined. Other functions are continuous everywhere, and it turns out that most of the functions that we've studied in our pre-calculus classes are actually at least continuous where they're defined. So let's kind of take a look at some of these. So from your algebra classes, you would have studied some different kinds of functions, including things like power functions with a positive power, polynomial functions, that includes linear functions, quadratic functions, constant functions, rational functions if the denominator is never zero, exponential functions, logarithmic functions, and logistics functions. All of those functions there are continuous functions. In fact, most of those are, the domain is all real numbers. That's true for logistics functions, exponential functions, rational functions if the denominator is never zero, including polynomial functions, and some power functions with the positive power. Their domain is all real numbers, and so they're just one connected piece from minus infinity to infinity. Some power functions with the positive power, for example, power 1/2, the square root function, it's a continuous function, but it's only defined for non-negative inputs. So it's still one connected piece, it's still a continuous function, but there are some places where the function's undefined. Okay. Logarithmic functions are another one that are only defined for positive numbers. So it's still the interval from 0 to infinity. It's one single interval of real numbers, and it's continuous everywhere it's defined. Now, from trigonometry, the basic sine and cosine graphs are continuous functions, and they're defined for all real numbers. The inverse trig functions, arcsine, arccosine, arctangent, and arccotangent, are all continuous functions, at least the way I define them and the way they are usually defined. And from statistics, the most important curve in statistics, the normal probability density function, the PDF of that is a continuous function. And in statistics, any cumulative density function, CDF, for continuous distribution is actually a continuous function. That's why it's called a continuous distribution. So you're supposed to know something about at least algebra and trigonometry before you get to calculus, and of course it's useful to know some things about statistics for everybody at some point. So those things are related there. Now, we also have some functions that are not continuous functions, but they're continuous wherever they're defined. Okay, so the only discontinuities are going to be where the x values where they're undefined. So power functions where it has a 0 or a negative power are going to have discontinuities at 0, because 0 to the 0 or 0 to negative power is undefined, and the graph is going to break there they're going to be not continuous. With the negative power, some of those are not continuous functions, but they're definitely, all of them are undefined at x equals 0. Rational functions, if the denominator can become 0, then the rational functions have discontinuities at those places where the denominator is 0. We've already looked at some examples of this, and those functions will have either a hole in a graph or a vertical asymptote there. Another type of thing that has some discontinuities is a greatest integer function, but it is, everywhere it's defined, actually that is not true. It is not continuous everywhere it's defined. So I'm going to take that one away. From trigonometry, our other basic trig functions, tangent, cotangent, secant, and cosecant, all have discontinuities in them. They're all, in fact, they have infinitely many discontinuities that are periodically placed there. And the arcsecant and arccosecant functions also have a big break in the middle between -1 and 1, where they're undefined. So the graph is in two separate pieces, so it's definitely not a continuous function. A uniform probability density function technically is defined for all real numbers, so it's in 3 pieces, and those 3 pieces are disconnected when you look at the PDF. Okay, so those are some examples of some functions, some continuous functions, and some functions that are continuous where they're defined, but not continuous everywhere. Now remember, when I talk about continuity, we're talking about continuity at a point, and then we can talk about a continuous function. Continuity at a point, we know, means the limit exists, the function exists, and they're the same. So if you draw, graphically, if you draw a little circle around that point, if the circle is small enough, you can draw the graph as one connected piece within that circle. However, if it's a continuous function, that means the entire graph can be drawn as one connected piece. Okay, so it's continuous everywhere it's defined, and that's all that's defined as one connected interval. So we have some lists here, and what we're going to do is we're going to basically take each of these type of functions, and maybe a few others, and kind of just give a really brief overview of some of their main characteristics, and in some cases we'll prove these things that are continuous. And we'll be doing that in our next series of videos here.